Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0134 indicates a malfunction in the heater system of the rear air-fuel AF sensor located on Bank 1, Sensor 1 of the Honda Pilot models from 2016 to 2022. This component plays a crucial role in monitoring the air-fuel mixture for optimal combustion in the engine's exhaust system. The sensor generates a voltage signal that varies according to the air-fuel mix's richness. If the signal indicates a lean or rich condition, various engine functions can be adjusted accordingly. The heater element within the sensor is essential for maintaining proper operational temperature, especially during cold starts. A malfunction here could lead to poor engine performance, reduced fuel efficiency, and potentially harmful emissions. Understanding the implications of this code is the first step in addressing the underlying issue effectively. The DTC P0134 describes a malfunction in the rear air-fuel sensor's heater system on Bank 1, Sensor 1. The rear AF sensor is a vital component situated in the exhaust system, tasked with measuring the amount of oxygen present in the exhaust gases. This measurement is critical for the engine control module, ECM, to adjust fuel injection to the optimal ratio for combustion. The heater element within this sensor ensures it operates effectively, especially during cold vehicle starts when exhaust gases may not create enough heat for sensing. If this heater system fails, it can lead to incorrect readings, which can ultimately affect engine performance and emissions. Knowing the specific location and function of this sensor helps in targeting the troubleshooting process effectively. Several potential causes exist for DTC P0134, primarily centered around the rear AF sensor's heater and related wiring. A failure in the heater element itself is often the primary culprit. If the heater is not functioning, the sensor may not reach the operational temperature required for accurate readings, resulting in malfunction. Additionally, wiring issues, such as shorts or open circuits, can interrupt the electrical flow necessary for the heater's operation. Poor connections at the AF sensor or the powertrain control module, PCM, can also contribute to this fault. Lastly, if the PCM itself has developed a malfunction, it may not be processing the signals correctly, leading to the DTC being triggered. Identifying the specific issue requires thorough testing of each of these components and their connections. The manifestation of DTC P0134 can lead to several noticeable symptoms that can affect the vehicle's overall performance. Often, the first indication is illumination of the check engine light, alerting the driver that there is an issue requiring attention. Alongside this, drivers may experience poor fuel economy as the engine fails to achieve optimal air-fuel ratios. This inefficiency can lead to a rough idle, where the engine stability diminishes, causing it to shake or vibrate unpredictably. Moreover, increased emissions can be a significant concern, especially in regions with strict environmental regulations. Understanding these symptoms can help in assessing the immediate impacts of the DTC and the urgency with which repairs should be made. The first troubleshooting step involves verifying the state of the DTC P0134 by switching the vehicle to the on position without starting the engine. This preliminary action prepares the vehicle for diagnostic testing. Following this, the next step is to clear the DTC using the Honda Diagnostic System, HDS. This resets the system's DTC memory. After clearing the DTC, it is essential to start the engine and allow it to idle for at least 1 minute without additional load, ensuring the engine reaches optimal conditions for testing. Once completed, recheck for any pending or confirmed DTCs using the HDS. If P0134 returns, it indicates the failure persists, warranting further investigation in subsequent troubleshooting steps. In the second troubleshooting step, begin by turning the vehicle to the off lock mode, ensuring all systems are inactive. Next, utilize the HDS to jump the SCS, simultaneous communication service line, which allows for deeper diagnostics to be run. After waiting more than 1 minute, disconnect the connectors for both the air-fuel sensor and the PCM powertrain control module to isolate the components for further testing. It is crucial to accurately check continuity between specified test points, a fuel sensor connector number 6, and the corresponding pins on the PCM connector. Confirming continuity at this stage is vital, as it assesses the integrity of the circuit. If continuity is confirmed, proceed to the next diagnostic step. Otherwise, repair any detected open circuits in the wires. The third troubleshooting step entails reconnecting the PCM connector, ensuring that all diagnostic connections are intact for accurate measurements. Exit the SCS mode using the HDS to return the system to its normal operating state. Once in this mode, start the engine and let it idle without any load for a minimum of 1 minute, allowing the PCM and sensors to perform diagnostics accurately. Subsequently, measure the voltage between the designated test points within the air-fuel sensor connector and body ground to determine the voltage output from the heater circuit. A normal output of around 0.2 volts or less indicates that the heater system might be functioning correctly. If the measurements deviate from this threshold, consider checking for authorized service information or replacing the A-fuel sensor based on diagnosis. After completing repairs related to DTC P0134, perform a final verification process to ensure that the issue has been effectively resolved. Begin by confirming that the DTC has been cleared from the system after repair. Following this, it is imperative to retest the vehicle under normal driving conditions to ascertain whether the issue reoccurs. Pay careful attention to how the engine operates, particularly monitoring for any performance issues such as poor fuel economy or rough idling. If the DTC does not return and the engine functions smoothly, it can be concluded that the repairs were successful. Regular monitoring and rechecking the vehicle post-repair can prevent future issues and provide assurance of sustained vehicle performance. In order to prevent future occurrences of DTC P0134 and ensure optimal vehicle performance, proactively maintaining the AF sensor system is crucial. Regular checks on the air-fuel sensors can help identify potential issues before they escalate into more serious malfunctions. Inspecting the wiring and connections associated with the AF sensors for wear or corrosion can help assure the electrical integrity required for proper sensor operation. Maintaining the health of the powertrain control module PCM through successful software updates or recalibrations when necessary can also support the overall system's efficiency. Adopting a preventive maintenance approach significantly contributes to avoiding unplanned repairs and enhances engine functionality. In conclusion, understanding the implications of DTC P0134 and its relation to the rear air-fuel sensor heater system is essential for any Honda Pilot owner. Following a structured troubleshooting process ensures that technicians can effectively diagnose and rectify issues that may arise. Frequent preventive maintenance checks can significantly reduce the likelihood of such DTCs appearing in the future. By staying informed about the condition of critical components, such as the air-fuel sensor and its connections, both performance and emissions can be optimized. Being proactive not only extends the vehicle's life, but also enhances the overall driving experience, making it invaluable for any Honda Pilot driver looking to maintain their vehicle in prime condition. Please like and subscribe to the channel. See you next time.